Hey everyone, Johnny here. Welcome to another video. Today we're going to be looking at how to find any term in an arithmetic progression. That is an AP, we'll call for short. So the first step to actually do it before I go into the formula is to first of all establish that you have an AP. An AP is a pattern in which the numbers are increasing by the same amount each time. So when you get a question that wants you to find a particular term in an AP, right? So imagine you have a pattern here where you have a list of numbers, 10, 15, 20, and so on, and a question says find the 100th number in this pattern, right? The first thing you do, always the first step, is to prove that in fact you have an AP. If you don't have a pattern that is called an arithmetic progression, then you don't use the formulas to do with an AP. Okay, so the first thing, this is like the antecedent step. This is the step you do before you actually apply the formula, and you do this for GPs as well, is you first of all prove that you have an AP. So if we have 10, 15, and 20, the test you always do to prove that something is an AP is to prove that the numbers are going up by the same amount. That is, that they have the same difference between them, right? So I'm interested in what's happening between 10 and 15. What's happening between 15 and 20? I want to make sure that the difference between each of these numbers is the same each time. So the official test is you get the third term and you minus the second term, and then you see that that is equal to the second term minus the first term, right? So this is the test for an AP. Right? If you don't have an AP, don't worry about this formula up here to find any term because it's not relevant. Okay? So we test for the AP. What is the third term here? Well, you always look in order. So the first term you see on the left is T1. Okay? I'll just put that. That's T1. That's our second term. T2 is 15. 20 is our third term, so we call that T3, term 3. Okay? And so on. Now, the third term, 20, minus the second term, 15. We have to see that it is equal to 15 minus 10. So we have 20 minus 15, which is 5. 15 minus 10 is 5. There you go. The numbers are the same on both sides. So we give it a tick. And we say, therefore, we do have an AP. And we also know from looking at the difference there that the common difference, which we call D, right? We call this D. The common difference. D equals 5. Because you can see here that each time we go to the next number, we are going up by 5. So this is different to a GP where the numbers multiply by the same number each time. This is all about plussing by the same number, which can include negatives. So in other words, you could actually be minusing by the same number in a way. Okay, so it could be 10 minus 5 is 5. 5 minus 5 is 0. That would also be an AP. Okay? But different to a GP, because a GP is where you'd be multiplying by the same number, including fractions and including negative numbers. Now, when you write this here in your working, we say that it has a difference of 5. You also want to mention that the first term is always important with these kind of series and sequences. A equals 10. Okay, you can see that here. Okay, so T1, the first term, is what we call A. So A represents the first term in the pattern or the sequence that you are looking at, whether it's an AP or a GP. Okay, now that we've proven that we have an AP, now we need to be able to figure out how to find any particular term in this series. Because I put a ... clearly this goes forever. 10, 15, 20, 25, 30, 35, 40. What if I wanted you to find the 100th term in this progression? Are you really going to want to write out 100 numbers in a row to find out that 100th term? Probably not. So as long as you can prove you have an AP, we have a neat formula that you can use to get to any particular term straight away. So what I'm now going to show you is where this formula comes from, and then we'll apply it to an example. Okay, so this is the second element of this video. Now we're going to look at where the formula comes from. Let's have a look at these numbers here in this example, 10, 15, 20. How do we get from 10 to 15. Okay, so remember, we have 10, which is our first term. This is important. This is our A. That's our starting point. How do we get to 15? Well, we plus by the difference. Now, notice I'm not writing plus 5, even though in this example it is plus 5, because we're trying to come up with a general formula. I want a formula that will work for any type of pattern that is an AP, not just 10, 15, 20 specifically, okay? So we have the first term, and you plus the difference, which is 5 here, to get to the next one. And remember, the next one is T2. Okay, and then how do we get from 15 to 20, which is T3? Well, you get to T3 by basically getting the second term and plussing the difference onto that. Now, if I list out what we've just done here, basically to get to T2, what we did was we had our first term and we plussed the difference. Then, to get to our third term, okay, we actually got the second term, this second term here, and then what we did is we plussed the difference again to that. Okay, so the important thing is here, to get to the third term, we had to get the second term and add the 5, add the difference, right? 15 plus 5 gave us 20. Notice here how I've written T2, which is the same as this. If I substitute now, T2 equals A plus D. So remember, T2 here is the same as A, the first term, plus the difference, right? Remember, 20 is the same as 10 plus 5, which is 15, plus another 5, basically, okay? So have a look at this. Another way of writing this is A plus D. Remember, that represents the second term. A plus D was the second term. And then we obviously add on our D here, the difference again, we add this. Because we need to add another we need to add another 5 to get to the third term. We can then simplify this A plus D, right? We can simplify this to A plus 2D. Because D plus D are like terms, so they become 2D. So what we have here is we have a pattern emerging. Try and see the pattern. When I wanted to find the second term, it equaled the first term, which is called A, plus the difference. But notice, what's really important here for you to understand is that before that D is an invisible 1. There is a 1 in front of that D. It's invisible. We don't have to write it. But notice here that if we want to find the second term that I've circled, you need to get the first term and add 1 of the difference. 1 times the difference, which was 5. If you want to find the third term, you need to get again, you just get 1 of the first term. It's A and A in both cases. So we're trying to find the pattern here. Plus 2 of the difference. But notice that the number 2 is 1 less than 3. And notice that back up here, the number 1 was 1 less than 2. So if you want to find any term, for instance, the fourth term, it seems that the pattern tells us to do this. Get the first term and add 1 less of that number times the difference. So for 4, I'm going to put 3. Hopefully you got that. Because the 4 is there, it means I have to add 3 of the difference plus that first term. So that's the pattern that we're seeing. So therefore, we can generalize the formula now. We can generalize it for any term. So the nth term. So T100, T1000, any numbered term, any nth term, right, is going to be A plus 1 less than that number. So if it was 100, it would be 99. So it's going to be N minus 1. Because if it was T100, we want to find 100 minus 1, which is 99, times the difference. So you see there, from looking at the first few examples in this case, we get that nice formula that we can use to find any term. So the last step here is to now take that formula. We're going to take that formula and we are going to use it in an example. E.g., let's use it in the example of finding the 10th term. So T10, right? Remember, the whole idea here is we have a pattern of numbers and we want to have a shortcut. This is a shortcut to find any particular term in the pattern so that I don't have to write out every single term to get there. Okay, so the shortcut here is instead of writing 7 more numbers to get to the 10th term and just keep adding 5 each time, I can just go T10 equals A, which is 10. Remember, the first term is A, plus n minus 1 in brackets. Important to do the brackets, which is 10 minus 1 times, there is an invisible times between the bracket and the letter D. So I can just write in times for your understanding. Times the difference, and the difference here was positive 5. If it was negative, I would have to include a negative. So you'd be multiplying by negative 5 if it was going down by 5 each time. Okay, so T10 equals this. So then we have 10 plus, what's 10 minus 1? 9 times 5. Now remember, order of operations here. You don't do 10 plus 9. You always do times before pluses. So I'm going to put that in brackets to make that clear. So it is 9 times 5. So it is 10 plus 45. 10 plus 45, which equals 55. Okay, so the answer here is that the 10th term, if I was to keep writing these out 10 times, 10, 15, 20, 25, and I did that to the 10th number, I would get to 55, but I've used the formula that I showed you how to get there in a quicker way. So you could find the 1000th number without writing them all out. All right, I hope that helps you guys. If you did enjoy the video, please like, subscribe to the channel if you want more of these videos, and I will see you in the next one.